Alright guys, so today we're going to go ahead and move on to the law of logarithms, but before that, can't talk today, we are going to refresh our memory and have a quick little bell ringer of what we did last time. So we want to find what the value of x is. So in this first one, 4 to the second will give me that value of x. So we knew that 4 squared is 16. We know that when there's no base, there's an invisible 10. So 10 to what power will give me 10? Well, that, of course, has to be 1. And lastly, 2 to what power will give me 32? Now, this one's a little bit trickier. But let me know what you get. Good, 5. All right. So moving forward, we're going to talk about the laws of logarithms. So these laws are very similar to the ones that we have talked about with exponential functions, so being able to solve. So keep that in mind as we start going through those. Think of your laws of your exponents. So my first one, and I'm going to make this a little skinnier so it's easier for me to write. We're going to do it in blue. We're going to have the log base b of m times n is equal to the log base b of m plus the log base b of n. So my little note here, my start moment, my aha thing, is that multiplication turns into addition. All right, my second law tells me that log base b of m divided by n is equal to log base b of m minus the log base b of n. So my aha moment here is division turns into subtraction. So multiplication, addition, division, subtraction, they're buddies. My third rule tells me that, can you see me? Can you see everything? Okay, I'm going to scroll up just a smidge. Log base b of m is equal to log base b of n if and only if m is equal to n. So I get to say that those guys are equal when I have equal stuff. Kind of makes sense there. And my last one. Log base b, oops, sorry, let's try that again. Tried to make that a capital B, of m to the k exponent is equal to k times log base b of m. So my little note here is exponents become coefficients. I must take up the letters, I think. So we're going to go ahead and take those rules and we're going to put them into practice and manipulate some logarithmic functions. Alright, this first one, we're going to go ahead and expand this. So first things first is I see that the m to the fourth and n are held together with multiplication. So if I want to pull them apart with multiplication, do I use addition or subtraction? Addition, good. So I have log Now, I don't necessarily have a base here because it's an invisible 10, so I just have log of m to the 4th plus log of n. Well, now taking a look at both of my pieces, I see I have an exponential guy, and we know that we have a law for him. We just talked about it. It's an exponent, and exponents become coefficients, and coefficients mean it's just a number in front of something. So to fully simplify to fully expand this, that 4 has to come out front. So I have 4 log of m plus log of n. And everything is pulled down or, sorry, something on my computer screen. Everything is pulled down or pulled apart as much as I can, so that's my final answer. Alrighty, let's go ahead and take a look at the second one. We know that we have division, so division deals with what operation? Addition or subtraction? Good, subtraction. So I have log of m to the 6th minus log of n. And again, I have an exponent here, so I go ahead and bring him down by making him a coefficient. I don't have any other multiplication or exponents going on. I don't have anything else. I've expanded him as much as I can, so that is my final answer. Now this next one is missing. It's supposed to say log of the square root of m times n. Now, this one is different, not any harder. Think back for a moment about when we turned square roots and other kind of radicals into exponents. What exponents was the square root? We're going to have log of m times n to some exponential power, and this exponent's going to be a fraction. What was that fraction? Well, what power is both of the m and n to? Well, an invisible first, because as long as it's there, there's an invisible first power. What type of radical is a square root? That's square root. What number do we associate with square? 2. So he gets to the 1/2 power. And we've already worked with exponents. We know that everything in that set of parentheses can go ahead and get that exponent. So I have log of m to the 1/2, n to the 1/2. Now we can go ahead and simplify because I have gotten rid of my parentheses. And we know that m to the 1/2 and n to the 1/2 are being held with multiplication. And multiplication splits into addition. So I have log of m to the 1/2 plus log of n to the 1/2. And again, we see we have now exponents going on in there. Right here and here. And we know that exponents come down as a coefficient. So I have 1/2 log of m plus 1/2 log of n. And nothing else can be simplified, taken away, or expanded. So therefore, that's my final answer. Alright, let's go backwards. Let's take something that's expanded and simplify it. Well, first things first is I see I have a coefficient out front of 2, and 2 in my coefficients, well, it turns into a coefficient. An exponent. So if an exponent turns into a coefficient, doesn't it logically have to go back and turn into an exponent? So this turns into log of 45 minus log of 3 squared. And we know that 3 squared is simply, very good, 9. So I have log of 45 minus log of 9. And what mathematical operation did subtraction deal with? Multiplication or division? Division, good. So then I can put this together by saying log of 45 divided by 9. Someone refresh my memory. What is 45 divided by 9? Good. So my answer here is log of 5. If I can, I'm going to simplify it out as far as I can. There you go. Sorry about that, guys. Okay, let's go ahead and take a look at this next one. Now, I have addition and subtraction going on at the same time. So what I do is I read this mathematical statement like I read a sentence. So because I come across the addition first, I have to do that operation first. So we're going to go ahead and focus on that first part. So addition was what? Multiplication or division? Good, it's multiplication. So I'm going to have log of 4 times 6 minus log of 2. Well, what is 4 times 6? Good, it gives me 24. So now that I've simplified that, I have log of 24 minus log of 2, and which one was subtraction again? Oh, right, it was division. We saw it over there. So then I have log of 24 divided by 2, and 24 divided by 2 gives me, good, 12. So my answer is log of 12. All right, last one. So just again, like we saw in the one before, I have addition and subtraction going on at the same time. So I'm going to go ahead and focus on the first two because I read left to right, and I go ahead and do those first two operations going on there. So addition again is going to be multiplication. So I'm going to go ahead and stick those guys together with log of m times n. And since these are just variables, I don't have anything to physically simplify. I don't have numbers. So now I have log of mn minus 5 log of p. But I know that I have a coefficient, and I can't put something together until that coefficient's gone away, so I have to go ahead and change that. Coefficients turn into... Oops, I can't write today. Good, coefficients turn into exponents. So I have minus log of p to the 5th. And then now I have subtraction, which turns into... Good, division. So division, I have log of mn to the, over p to the 5th. And since these are all variables, I can't simplify anything, so it's as simplified as I possibly can get. So my answer is log of m times n over p to the 5th. Alright guys, have fun.